Hi everyone, so we'll start now. Okay, so today we're gonna learn about different shapes and what their area or volumes are. So area, area is basically like how much space something will take up, and then volume is like that, but like in 3 dimensions instead of just 2. So for area, we'll go over squares, rectangles, and triangles, and then like combinations of these shapes. And then for volume, we'll go over cube, rectangular, prisms, and then like a combination of the two. Okay, so area, like let's take your room for example. Imagine your room was a square. All the things you can fit in this square would be your area. So area can be measured in 3D and 2D shapes. Area in 2D shapes is like how many papers you can fit on the floor. But like for 3D shapes, it would be like how many boxes can you fit in your room. Area in 2D shapes is called area, and then area in 3D shapes is called volume. This is just like a fun question. Do you guys want to guess who invented volume? You can like put your answers in the chat or something like that.
Please, was it Albert Einstein?
Oh, it's one of these 3 options. I don't think Albert Einstein is one of the 3 or like the 4 options. So there's
Socrates.
Okay.
Socrates.
Let's see. It's not Socrates, it's Archimedes. Yeah. Just like a little fun question, I guess. Okay. So for general terms, the length of is like a side of a 2D shape and 3D shape. So if I were to draw let's say like a square and then like a prism or like a cube. Okay, so the length on the square would be like this. Oh. Let me see if I can fix my audio. Okay, is this better? Oops. Okay. So the okay. Wait, so on the square this would be the length. And then
I can't hear you.
Let me see. Is this better? Wait, can you guys hear me now? Or
Yes, we can hear you.
oh, okay. Yeah, so this one is 3D and then this one is 2D. So the length would be like the side. So like the length on the square would be like that. And then the length on here would be like this. And then the width is like the second dimension. So it'd be like here and like here. Okay. So it'd be like length, width, and then height is only for 3D shapes, and that's basically like how tall it is. So the way you build up a 3D shape, it's basically like if I were to draw a 3D shape here. you have this starting shape like here. So it's just this one square. And you multiply this by the height to get the volume. So this part, this red square over here, this is called the base of the 3D square, or the 3D shape. And you calculate it by doing length times width. Okay? Okay, I'm gonna move on. Okay, so let's calculate some area, or let's just kind of see how area works. So let's see how many squares we can fit in this bigger square. Does anyone want to make a guess on how many squares we could fit? How many do you guys think we can fit in the bigger square?
I guess 4.
4? Okay. Anyone else have a guess? Okay.
40.
Okay. Let's see who's right or who's close.
Yes, I guess 9.
Okay, so we can fit 1, 2, 3, 4. Okay, so we fit 4, but let's see if we can add more. 5, 6, 7, 8, 9. We can fit 9 squares or 9 small squares in that one big square. So if we're looking at area, we would consider this area to be 9 and then units squared. Yeah. Okay. Let's keep going. Okay, now let's look at volume. So just like some fun facts, 50 centimeters cubed. So volume is always in cubic units. Volume is always some unit cubed, and area is always some unit squared. So that's how you kind of tell the difference. So 50 centimeters cubed equals 1 million grains of sugar. So just imagine 1 million grains of sugar only take up 50 centimeters cubed. And then 100 centimeters cubed is like the volume of a T-Rex's brain. So it's pretty cool. And then 40 centimeters cubed is the volume of salt in a human. So like basically how much salt is in each one of your bodies is 140 centimeters cubed, or about that much. And then 450 centimeters cubed is the volume of body cells that die in a day. And then 600 centimeters cubed is the volume of a human brain. So I just thought those were some pretty fun facts, so I just included them. Okay, we'll move on. Okay, so we'll first look at like squares and cubes. So when we're finding the area of a 3D shape or a 2D shape, you always add the cubed for volume and the squared symbol at the end of your answer. So basically, the way to sort of think about it is that if you have a square, you have x units here and y units here. So when you multiply them together, you get like xu times yu. So you end up with xyu squared. So that's why there's a square there. And then if you think about volume, instead of multiplying only 2 of these, you actually multiply 3. So you have xu, yu, and then zu. So when you multiply all of these together, you get x, y, z, u cubed. So that's why they're sort of like squares and cubes. Does anyone have any questions?
Understand how you gave the answer.
How you get the answer?
So like this, I don't understand what you just put on the whiteboard.
Oh, okay. So basically, when you're okay, so let's say you have, let's go back to the square. Okay, so this is a square. It's 2D, right? There's only 2 dimensions being used here, the length and the width, right? So in order to find the area, so you find the area, you multiply the length times the width. And because the length is in x units and the width is in y, or like the same units, when you multiply these together, you should end up with the units squared when you give your answer. So let's say this was 3 centimeters by 3 centimeters. Then our area would be 9 centimeters squared. So I was just telling you, like, when you're dealing with area in 2 dimensions, you put a square or like a power of 2 on the units. And when you're dealing with volume, which is something we'll talk about a little later, you always put cubed. So I was just talking about like convention and how you should like label stuff. Does that make a little more sense?
I don't understand.
Okay. Let me see how to, okay, we'll go back here. So when you're finding the area of a 2D shape, so let's take the square again. Basically, we're finding how many of these smaller squares can fit in this bigger square. That's gonna give us our area. Does that part make sense?
Yes.
What area is? Okay. So with all like I guess these things with like shapes, there's always units attached to it. So basically like when you're measuring something, you can measure in meters or you can measure in yards or something like that, right? There are different units of measurements. So when you're dealing with area, there's also a measurement unit added. So it's important to add units when you're dealing with area. Does that part make sense?
Yes.
Okay. So when you have these units, you have to be sure to add a square sign or a cube sign for units. Because when you have a square, let's say, this side, okay, so the area of a square is going to be this side, which is called the length, times this side, which is called the width. So we're going to do length times width.
iPad, please, I don't always right.
Huh? Sorry, I couldn't hear what you said. Could you
So,
repeat?
madam, please, I trying to say that anytime you are dealing with mostly 2D shapes, what you must always use the units.
Yeah, but you always have to make sure you put the square sign because that signifies that it's in 2D. And then when you add the units cube sign, that will signify it's in 3D. Does that part make sense?
Yes.
Okay, so that's what we're gonna do. Okay. So I just suggest you like write down these formulas on a piece of paper so that you can like, because we'll use these formulas to solve some practice problems later, so just like make sure you have them. So the first one is like the area of a square, which we kind of went over already, but the area of a square is going to be its length times its width.
Madam,
Yeah?
is I the one who is writing on the board or is iPad?
Oh, that's me. Don't worry about that. Was everyone able to copy down this formula?
Yes.
Yeah? Okay. So then we'll move to the next one. Okay, so this is where it gets a little complicated. So, let's start simple. So, the formula for the area of the triangle is going to be its length times its width.
Turn around. Turn around.
Okay, so the area of a triangle is going to be its length and width divided by 2. So let's say we're looking at this triangle. The reason we have this sort of formula for a triangle is actually based on like the square and rectangle one. So if we draw a square or a rectangle and we divide it in 2, we actually get 2 triangles. So what this tells us is that when we have a triangle with side lengths of like L and W, it's actually going to be 1/2 the area of a square, which is length times width. Yeah? Do you have a question? Does anyone have a question? Oh.
No, please.
No? Okay. Okay. So there are, whoever is raising their hand, do you have a question?
Please.
Could you say that again? I think you like cut out.
I said my screen keeps on blinking, so I don't get the time to read. It becomes bigger and smaller, so I don't get the time to read the formula.
Oh, okay. So basically the only formula we went over was the formula for a square and a rectangle, which is just length times width. So that's just all you need to have noted down. I can like put them in the chat room as well, so that way everyone can see it. Okay. So there are 3 types of triangles. So one is called a right triangle. One is called an isosceles triangle.
Yeah, I've heard that before.
We've went over this before?
Yeah, in school.
Oh, okay. Okay. Oops.
Isosceles triangle, equilateral triangle.
Yeah. Yeah, I'm just gonna clear everything, then I'll write it again. We'll just review it, I guess. So we have a right triangle, equilateral triangle, and oops. An isosceles triangle. Okay. So a right triangle is okay. Hold on, let me just fix this. Alright, so we have equilateral, isosceles, and right. So we'll start off with the right triangle. So all a right triangle is it's just a triangle with the right angle. So the triangle just has a right angle, and that's what qualifies it as a right triangle. And so the way you would find this area, it would just be this side, its length, times its width. That would give you the area, or like 1/2. It'd be just 1/2 length times the width. For an equilateral triangle, what that means is that all the sides are the same. So if this like side is like has a value of A, then this one will too, and then this one will as well. And these angles will all be 60 degrees. So with equilateral triangles, it's a bit different. You actually have to split it up into two right triangles. So you draw a line right here. You draw a line right down the center, and you'd form two right triangles. And so let's call this height h. So the area of an equilateral triangle would be 1/2 a times h. And you would need to solve for a or h. Given that this is a and this is a over 2. And then last one we'll go over is like isosceles triangle, which is where the two of the side lengths equal each other, but the third one is not equal. So let's say we have this one as A, then this one would be A. And because their side lengths are equal, these angles over here are also equal. So we'll call them X and X. So, and then we'd have this as like B. It'd be a completely different number. And so again, you're gonna split it into two right triangles. And you're given that this will be B over 2, and this will be B over 2.
I'm still not getting a hang of it.
Which one? The equilateral, right, isosceles, or like all three?
It's like all three. It's a bit confusing.
Okay, yeah, I get that. Okay, so let me just go over like all slowly, I guess. So with a right triangle, it's pretty straightforward when you want to find the area. For the area, you just do this side, this length, times this width. And that would give you your area. Or like you do 1/2 of that to get your area. Does that part make sense for the right triangle?
Yes.
Okay, so
But
now,
could you go over one more time so I can make sure?
yeah. Okay, so for a right triangle, you do the length with which is like this side, times the width, and then you take 1/2 of that. So it'd be like this formula over here. Does that make sense?
Yes, please.
Okay, so now we'll go on to equilateral triangles. So equilateral triangles, the way you should kind of like, I guess, try and find the area would be to split the equilateral triangle in half into 2 right triangles. So you would have one right triangle right here. So you'd have one right triangle right here, and then another one right here. Does that part make sense?
So you're saying that if you have an equilateral triangle like this, if you have an equilateral triangle like this, and each side is 60 degrees.
Yeah.
Each side, the corners are 60 degrees.
Yeah.
And if you split it in half like this, and it generously becomes this a right triangle.
Yeah. So in an equilateral triangle, all the angles are the same and all the side lengths are the same. So once you split it into 2 right triangles, you can solve for height. You can solve for the height of the triangle. And so with the height of the triangle, you're going to multiply one of the side, or this side, like the bottom side, A, times the height, and do 1/2 of that. Does that part make sense?
Yes, please.
Okay. And then we'll go over an isosceles triangle, which is very similar to.
His auntie. Please, my sister was disturbing me, so please, can you start again?
Oh, okay. So I'll go over equilateral. Does anyone else want to try and explain equilateral triangles?
I want to explain it.
Okay, yeah, go ahead. Oh, can you like talk us through what you're sort of doing? Okay, I'll just like kind of talk you through it again, I guess. So basically there are 3 types of triangles.
I can't hear you clear.
Huh? Okay, there are three types of triangles. One is called a right triangle, which is like this one over here. Then one is called an equilateral triangle, which is this one over here. And then one is called isosceles. So in the right triangle, in order to find the area, you just do the length times the width divided by 2. So here's the formula for it. But for an equilateral triangle, you need to split it into two right triangles. So you'd split it down here into two right triangles. And then you'd solve for the height of the triangle using the right triangles. And then we'll go over an isosceles triangle. So for an isosceles triangle, two of the sides are the same, and so two of the angles in the isosceles triangle are the same. So if these two sides are equal, this side and this side, then these two angles are equal. And so once again, in order to find the area of the isosceles triangle, you split it down the middle into two right triangles. And you have another height. So what you're going to do in this case is, because you know that this side is going to be b over 2, or like basically it's going to be like the base of the triangle divided by 2, and this is going to be a, you can solve for h. So the area of an isosceles triangle is also 1/2 base times height. Does that make sense to everyone?
Yes.
Okay.
Yes, please.
No.
What part doesn't make sense?
The part that you said 1/2 equal p times.
Oh, okay, I see. So basically, whenever you have an equilateral or an isosceles triangle where two of the sides are equal, whenever you draw like a perpendicular line down, you will always end up with half of the base here and half of the base here. That's just like always given. So for an equilateral triangle, this would just be the side length over 2, so a over 2. But in an isosceles triangle, it would be like, if this is considered b, it would be b over 2 and b over 2. Does that make sense?
Yeah. Yep.
Yeah? Okay. If there's still a little confusion on how all this works, I think it'll be like cleared up when we do a little bit of like practice. So, yeah. Okay. So now,
Will you give us some practice problems?
huh?
So will you give us some practice problems?
Yeah. There's just like a few more things we need to go over before we can do the practice problems. Okay, so now we're gonna do a cube and a rectangular prism. So these are 3D shapes, as you can like see on the right. So they have 3 dimensions. So there's gonna be a length dimension, which is like this part, a width dimension, and a height dimension. So this height dimension is the new added dimension, which makes it 3D. So the formula for this is going to be length times width times height. So the way I think about it is, you're just gonna basically see, or like to find the volume, you're gonna, let's say, let's take this square at the top.
Madam, please, I think I learned something like this at school before. Please, can I draw something on the board so you can just check if it's the same thing?
Oh yeah, okay.
Okay, so please, what I'm trying to say is that this is what we learned. And if you pretend that the height is, let's say, The height was 3. The length was 4, and the width was 5. So basically, our teacher said, Coffee, please, I'm coming. You have 3 times 4 times 5. Hey, how do I do that?
Yeah, that's
Is that correct?
Yeah, that's the same idea.
So is my answer correct?
Yeah.
Thank you.
Okay, I'm just gonna erase this part. Okay. So the way I like to think about it, it's let's say we have this 2D square over here, which has an area of length times width. The volume is just gonna be like copying the square h times, or like the height amount of times, to get us our volume. Does that make sense?
Yes.
So our formula would be length times width times height. Okay, cool. So let's move on. Are there like any questions so far?
No,
Okay.
please.
So let's try this problem. What's the area of this rectangle? You guys can like message me, and don't forget the units. Make sure you add the units.
Should we privately message you on the
Yeah.
chat?
Yeah.
Please attempt problem. Please. What is the area of
4 times 8. No, 30.
a beneficiary? Uh, mm,
Okay. I think most of you are getting like the number answer correct, but I think there's still an issue with like the units. So I'll just go over this one so that we can get an idea of like how the units will work. So
please, can I say the answer I got?
uh
I got 24 feet a square.
yeah, so what you did right was you put feet squared, which is important because I think a lot of people missed out on feet squared. Remember, when we're dealing with area, always do units squared. Always do units squared. So in this case, our units are feet. So our area would be feet squared. Okay, so now that's all that's left to do is just follow the formula. So our formula for area is going to be length, which would be this, times width, which would be this. So we're giving that our length is 4 times our width, which gives us 32. So we have to put our units back on, so we get 32 feet squared as our answer. Does that make sense to everyone?
Yes.
Okay.
Yes, please.
Okay. Let's try another problem. How about the area of this square? So remember, within a square, all the sides are the same. So this side is going to be all equal. So they're all going to be 6 inches. 6 inches. 6 inches.
It's a private message.
Yeah. So I'm just going to give you guys a hint because I think this might have been a little bit confusing. The area for squares is the same as the area for a rectangle. So it's still length times width.
Please. Please, the answer is 36.
Please private message me your answer.
I'm so hard. Come on.
Okay, I'll give you guys a couple more minutes to
Now
attempt
you can talk now.
the problem and then
Please,
we can go over the solution.
please, the solution. The solution is. Please, the solution is 36.
Can you message me your answer? And I'll give you feedback.
Right. The Okay. Why did I make mistakes? Erase it. Erase it. Clean it up. Clean it. Now let's go back to the right hand. And I will write everywhere. Come on, why did this thing so terrible? Let's go here and right. So come on, why did you say so bad? I erased it. Now let's start again.
Do you guys want more time to attempt the problem, or do you want a solution?
It's a solution.
The solution?
Yes. Come on, it's crazy. Let's erase it.
Okay, so when we're looking at this problem, let's try and derive the units again. So let's take a look. So units are basically like, if you have
Come on.
inches, your units are inches. So it's basically how many of that unit is being used. If we look at our units,
Recording.
we have inches because the problem uses inches. And for area, we need to square the inches, right? So our unit is inches squared. So now let's calculate the area. So using the formula, length times width, we know that our length is 6 and our width is 6. So our area is going to be 6 times 6, or 36. And then we're going to put the inches squared back on. So our answer is going to be 36 inches squared. Does that make sense to everyone? Does everyone understand? Yeah. Okay. So let's try. I'm gonna try a different problem, but it will use like the same concepts. So let's say instead of being 6, let's say this thing was 12 feet and it's still a square. What would the area of this square be? I'm gonna give you guys some time to try it. It's very similar to the problem we just did. So I'm gonna see if you guys can do it. Remember the units need to be squared or cubed depending on what what type of shape you're trying to find the area as well. So don't forget the units.
How will I do this? Right?
Remember for area in 2D, it's always units squared. And for volume, it'd be units cubed. So in this case, what would you use and what would the unit be?
in theory. I've sent my answer.
Whoever's drawing on the board, can you please stop drawing rhombuses? So in this case, you're just applying the formula. Area equals length times width. So all you need to figure out is what is the length and what is the width, and then multiply them together, then stick on the appropriate units. I'll give you guys a little more time to think about it. Does anyone have any questions or anything? Like, does this make sense?
Let's choose by eraser.
Okay, I think people are starting to get it now. So if you haven't sent in your answer, please send in an answer.
Please.
Okay, so I'll go over the solution. I think everyone understands how to use the formula, but again, be careful of units. Remember, you always should square the units when you're dealing with it. So I think everyone got the right unit, which was feet. So this is the unit. But when dealing with area, you need to put feet squared or inches squared or something squared. So the area in this case, this is the length. This is also 12 because it's a square, so all sides are equal. So this would be 12. So we have our length is 12 and our width is also 12. So our area would be 12 times 12 or 144 squared. Does that make sense to everyone?
Yes.
Yeah? Okay.
Oh, I know that.
Okay, so now let's try with a rectangular prism. Remember, this is a 3D shape. So your units should be, okay, I'll give you guys some time to try this problem.
6. So 6 times 6 times. This time. I have sent my answer.
Okay.
Please, I found the answer.
Yeah, I'm responding to everyone right now.
But it's 46. Okay. Come on.
Please,
Hmm?
please, there isn't the speaker on. Anytime, like he's calculating, he says his answers well. So please, could he mute it while he says his answers out loud?
Yeah.
But this I'm trying to say, a particular person, once he's solving the questions, he has his speaker on and it spoils the answers for the rest of us. So please, could he have his speaker on mute?
Yeah, I muted him. Thank you for letting me know. Okay. I'm gonna go over the solution for this one. So, can anyone tell me what the formula for area of a prism is?
Yes, please.
Yeah, go ahead.
Please, it goes like this. The area of this prism, a rectangular prism is simple. So you do your height times length times height times length times breadth, which is 6 times 2 times 3. 6 times 2 will give you 12. Then if you multiply 12 times 3, you get 36. So basically, 36 is your answer.
Yeah, that's correct. What would the unit be though for the answer?
And please, the unit here is 3, which means it has to be cube because 2 represents square, 2 represents square, and 3 represents cube.
Yeah. So the answer would be 36. Hmm. 36 meters cubed. Does anyone have any questions? No questions? Okay. So for these problems, it's just important to apply the formula. So if you're given all the dimensions, just use the formula to get them.
Come on.
Okay. We'll do another problem.
Anything Jeremiah said.
So this one's a little more confusing because they're multiple. Okay. There are multiple shapes within this one. So does anyone have an idea on how we could split this up so that it becomes a lot easier for us to solve?
Yes, please.
Yeah, so where should I draw the lines?
Please, if I was to give the answer for this, please, this is how I'll do it.
Shouting.
First, I will separate all the numbers with the dots in between, the decimal numbers. I'll separate all the decimal numbers from the numbers with no decimals. Then first I'll calculate the no decimal numbers, which is 2 plus 6, 2 plus 6 plus 3 plus 1. And 2 plus 6 is 8. 8 plus 3, 11. 11 plus 1, 12. So here is 12. Then next, I'll calculate the decimal numbers. 3.4 centimeters
Stop shouting. So you're
5
just here. No
dot
explain anyway.
5 centimeters. Then you have 2.5 centimeters. Then I also calculate that one. 4 plus 5 is 9. 9 plus 5 is 14. So I write my 4 here, then bring my 1 here. 3 plus 1 is 4. 4 plus 5 is 9. 9 plus 2 is 9 plus 2 is 11. Then I'll add this number 114 plus the 12. Then I'll calculate it. 4 plus 2 is 6. 1 plus 1 is 2. Then there's only 1 here, and there's nothing under. There's nothing under here to calculate it with. So if you leave the 1 on its own, then your answer definitely becomes 126.
So I think you were finding perimeter. So perimeter is just the sum of all the sides, but we need to find area. So we need to find how many blocks we can put inside here. So what I'm asking is like, we can see the shape is made up of many rectangles, right? Or like squares or like stuff like that we know how to calculate the area of. So how can we split this like seemingly complex shape into really simple ones? So let's take a look right here. So what if I just draw a line like this? And what if I draw a line like this? Well, now look, we have
A rectangle, a square, and a what?
we have one rectangle right here, another rectangle right here, and a third rectangle right here. Well, we know how to calculate areas of rectangles, so let's do that. But we have to be careful here because of the sides. So we need to be careful with the 5.5 and the 6 because we are splitting those into like rectangles with different lengths. So we know that within a rectangle, this side must be similar to this side, and this side must be equal to this side. So therefore, we know that this side is going to be 2.5. So then that leaves this side being 5.5 minus 2.5, right? Does everyone
So
understand?
that is 3.0.
Yeah, so this
I
one,
don't understand that, please.
okay, yeah. So you understood the rectangles, right? Like how we,
Wait, shouting.
like there's 3 rectangles. Did you get that part?
I don't understand why you put these lines here. Like,
Okay, so basically remember when we were dealing with like just simple shapes, we'd have a rectangle like this. This would be our rectangle, and we'd say this has like X length and this has Y length or something like that. So to calculate the area of this, it was relatively simple. We would just use the formula. Length times width. But in the case of this shape, we can't really do that because everything is not equal. Like the shape is not considered a rectangle. So we're going to try and break it down into rectangles so we can solve for the area of those rectangles and then just sum them up to find the area of the entire shape. Does that make sense?
Yes.
Yes, please.
Yes. So y times x cubed.
So we're going to put our lines back. So there are many ways to like split this up, but I just picked this one way because I thought it was the easiest. So yeah. Okay, so let's go back to how we basically should like find the, so in order to find the area of the rectangles, we need to know all the side lengths. So let's see how we can find all the side lengths of the rectangles. So let's first start off with finding, let's say, this side length. This is the side length that we're gonna find. Right? So we know that we've broken up our 5.5 side into, let's call this x, and then this would be 5.5 minus x, right? So we've split this up into x and 5.5 minus x. So in order to find this side length, we just need to find out what x is.
X means that's the thing we don't know.
So
X is 2.5.
yeah, so we got x equals 2.5.
X is the answer we don't know.
So we have a rectangle here, right? So our rectangle, within a rectangle, the opposite sides are equal. So what that's basically saying is that if this side is 2.5, then this side is also 2.5. And if this side is 3.4, then this entire side is also 3.4. So that's just a property of rectangles.
Times 3.4.
So then we get that x equals 2.5. Well, we can solve for this one, right? So what's 5.5 minus 2.5?
3.0.
Yeah, so we know our side length is going to be 3.
We just remembered it.
Okay, does that make sense to everyone?
Yes.
Yeah? Okay, so now let's try and solve for a different side. So let me erase this part. Okay, so okay,
I don't understand.
let me put this line back. So we know that this side is 3 centimeters. So now let's see if we can find, let's see, this side. Does anyone know how we should find it? This side right here. Does anyone want to guess?
I guess it would be 3.4 centimeters.
Okay, that's a good guess. But we should take into consideration that this entire side will be 3.4 centimeters. But I only want to find this little part about. So if we know that the whole side is 3.4 centimeters, what should we do to get this yellow part and not include the 2 centimeter part?
We'll have to subtract 2 centimeters from 3.4 centimeters.
Yeah, that's correct. So what does that give us if we do that? We subtract.
Can I see the
1.4 centimeters.
Yeah, so we know this side is 1.4 centimeters. Okay. So last question. This one should be sort of easy. What about this side? What's the length of that side?
One centimeter.
1 cent.
Yeah, it's 1 centimeter. Okay, so now we have all of our rectangles, right? So we have our first rectangle. Oops, let me just redraw this.
Yeah.
We have our first rectangle right here. That is 2.5 times 3.4. Then we have our middle rectangle, which is 1.4 times 3. And we have this small rectangle, which is 1 times 3. So now what we have to do is that we just have to figure out what these values are. So if we do 2.5 times 3.4, we get we get 8.5, I believe. Let me just double check. Yeah, we get 8.5. So what this is telling us is that our area of this rectangle is going to be 8.5 centimeters squared. Okay? So why don't you guys try and find the area of the middle one and the last one? What would these two areas be? Okay, how about we start with the middle one? Does anyone want to tell me what the area is?
The area for the second one is 3 points.
What?
Area for the second is 3.12.
3.2?
Wow.
The area is actually 4.2, but you were close, yeah. So if we multiply, we get 2, and then we have to carry over the 1. So we get 3 and then 4, so it would be 4.2. What are the units on this? Does anyone want to take a guess?
Centimeter square.
Yeah, it'd be centimeters squared. Okay, so our area for the second one would be 4.2 centimeters square. Let's write that down. 4.2 centimeters square. Okay, how about the last one?
3 centimeters square.
Yeah, okay. So now we have all of our areas. So all we have to do now is just add them all up to get our total area. So if we add them, what should we get?
— 12.7.
15.7 centimeter cube.
Centimeter
12.7.
square. Centimeter square. So let's see. Yeah, 15.7 centimeters square. Does that make sense to everyone?
Yes, please.
Yeah? Okay.
Please, I still don't understand it.
What part did you not get? Did you get like why we're splitting it up and then how we found the different side lengths, or?
And I please answer that then the whole area thing. I don't get the splitting up and how you got so your answer this. It's all confusing.
Okay. So, here, why don't we try a simpler shape? Maybe this will like make some concepts clear, I guess. Okay, so ignore this big shape there. Let's talk about this one. We have a shape that looks like that, right? And let's say this is 3, this is 2, this is 4, and this is 5. Right? Does that make sense? Let's pretend this is our shape.
Yes, please. Makes sense.
Okay, so when we look at this, we know directly we can't apply length times width because that requires it to look something like this, right? In order to apply length times width, right?
Yeah.
Yeah? Okay, so let's see how we can manipulate the shape in a way that we get shapes that look like that, so we can use length times width, right?
Yeah.
So let's see how we can break this shape up into shapes that look like that. So if I draw a line here, do we get shapes that look like that?
Madam, please, Evangelina said you should go over the area of the rectangles.
You want me to go over what the formula is for the area of a rectangle?
Not me, Evangelina.
Oh. Oh, okay, yeah. I can go over it. So basically just to find the area of a rectangle, you just take its length, which is this part, times its width, which is the other part. So this would be your length times your width. And then you multiply those together to get your area. That's just it. Okay, back to this example. So if I draw a line right here, do I get two shapes that look like rectangles? Yes, I do. So we have a rectangle that's 3 by 4, and we have another rectangle which is 5 by something. So how do we find that something? What should we do? Well, we know that in a rectangle that this side is equal to this side. So this side is also question mark.
Is that you say you wanted her to go over it? Yes. So she's going over it.
We?
So how should we find the question mark value?
Your screen.
Yeah, so so the question mark would equal 3 minus 2, which would give us 1, right?
Yes. Right.
Yeah, so now we have all of our rectangles, right? So we know that one is 3 by 4 and the other is 5 by 1. So now we can compute their areas, right? So if we compute the area, what are the areas of the two rectangles? Okay, how about what's the area of this one? What's the area of the 3 by 4 rectangle?
Well,
Yeah, it's 12. And then how about the 5 by 1?
5.
Yeah. So if we sum these areas, we get the answer as 17. And in this case, I didn't put any units, but if I were to put like feet or something, then our answer would be 17 feet squared. Okay, does that make sense to everyone? Kind of how to do these problems? Any questions?
No.
No? Okay,
What happened to it too?
let's move on then. Okay, this one is a little more complicated, but I'll give you guys some time to try it. Here's a little hint. You can already see two of these shapes, right? So basically this is what we did, but like 3D version. So you already have one shape right here, like this bottom shape. And then you also have a top shape. So it's already kind of split for you. So all you have to do is now you just have to find the different dimensions for the top shape and then sum up the volumes to get the answer. So I'll let you guys try it and then I'll go over the solution. Okay, I think this problem is a little hard, so we'll go over the answer together.
Okay.
I'm not sure why it's not working.
Okay. Okay. So is this our classwork?
It's not
So is
working.
this our classwork?
Wait, hold on one sec. It stopped working. So I don't know how to. Okay.
Okay.
Okay, there we go.
Okay.
So let's start by doing this. Let's break it up again, right? So where should I draw
Okay.
the line? Like, does anyone want to draw the line between the two prisms? Like, how should I divide this in a way that I can like easily do the math?
Can you see me now? Try and see if you can see.
Okay, so I'm going to divide it right here. So here is my first prism, this one, and then here is my second prism. So one is on top and then one is on the bottom.
Can you see me?
Does that make sense to everyone, the way I split it up?
Yeah.
Yeah? Okay. So now what we have to do is we have to find the side lengths. So for our bottom one, we actually are given all the side lengths we need. We have 10 by 3 by 2. So let's calculate the volume of the bottom one. So we know our volume equal to height times width times length, right? So our height for the bottom one is going to be equal to 10 times 3 times 2, or 60. Okay, so now let's try and figure out the top. So for the top, we know that this side length actually matches up with this one. So that means that they're the same length, because you can tell that there are no gaps, I guess. Like
Okay.
within the picture, there's no gaps between like this length exactly matches up with the length of the one on, or like the two lengths match up. Like, do people understand what I'm saying?
What?
Yeah? Okay. So this tells us that this is 3 centimeters, right? Because these two exactly like perfectly line up. There's no like this one wasn't drawn a couple centimeters back or something. So we know that they are exactly the same. Okay, so now we have one dimension left to find because we're given 4 and 3. So how are we going to find this dimension? Does anyone see any useful information that could help us? Okay, so the 6 centimeter is actually really useful, because what this is telling us is that if you draw a line here and it intersects here, it's telling us that this length is equal to 6, or like this length is equal to 6. So like excluding this portion from the 10, we get 6. Does that make sense to everyone?
No.
Okay. Let me try and do this again.
I don't get it.
Okay. So basically, what this 6 is telling us is that from, okay, let's look at it from like a top view. So if we look at it like this,
Madam, please, my laptop went out. Could you start explaining from the beginning?
yeah, I can explain it again. So, okay, I'll just start again. And if you guys have any questions along the way, please let me know. I think this one is a little bit tricky to understand, so we should just take our time with it. Okay, so the first thing I'm going to do when looking at this problem is I'm going to split the shape into 2 prisms. So we have our bottom prism. That's like this area. And we have our top prism. I'm pretty sure everyone understands this, right? Everyone understands how this splitting works, right?
Yes.
Yes? Okay. So now we need to find the lengths of this and this. So if we're looking at this part over here, we know that this side matches exactly with, so this width of this like sort of rectangular side matches exactly to this side. So like basically, if you look at it from a side view, it's gonna look something like this, where this part is the yellow part, where this part is the green part, and this part is the yellow part. Right? Does that make sense to everyone? If we basically look at this part only,
Yes, please.
okay, so if we look at this part only and we draw it like that, it's going to look like this. So we can tell that this side is going to match up with this side because it forms a rectangle, right? So we know the dimension of this bottom part is 3 centimeters, so that means this part has to be 3 centimeters. So that means this length is 3 centimeters. Okay? Everyone gets that?
Yeah.
Okay.
Yep.
So now I think the most confusing part was looking at the top part.
Yes.
Madam, please wait. So, if you are saying that this part is 3 centimeters, and this part is also 3 centimeters. This part, this whole place, what does it become? This, what does it become? The top, this top outer part, what does it become?
I don't think I understand the question. Could you ask it again?
Okay, madam, please, I'm trying to say that you said that this part is the yellow part is now 3 centimeters. You said it is now 3 centimeters. Understand? And if you come here, this line right here, this short line right here, you also say it's 3 centimeters. So if this line is 3 centimeters, this part, this whole place, the top here, this top part, how many centimeters is it?
Oh, so for the top part, like up here, it would also be 3 centimeters. But on the side, it's given as 4 centimeters. So we know that the side is 4 centimeters. Does that answer your question?
Yes, please.
Okay, so now let's look at the top part because I think everyone was confused on that. So if we look at this like top down, so if we look at it like this, we have the yellow part as this part, and it continues into here, and then this part is only green. Does that make sense to everyone, how this sort of looks?
Yes.
Okay, so we're given that this whole yellow portion is 10 centimeters. And then the 6 centimeters tells us that
Marina, please slow down a little.
what?
Slow
Yes.
down a little.
This 6 centimeters tells us that this portion, excluding the green,
Can't hear you clear.
huh?
Madam Varini,
Yeah?
please, if you do it
One
like
please, I
this,
can't hear you clear.
Varini, please, if you do it like this.
Can't hear you clear. Madam,
Yeah?
green. Varini Kadakia.
Yeah?
Madam,
Mm-hmm. Yeah?
Please, if we draw the down part or the
Madam, please can't
rectangle,
hear you clear.
then you also draw the top
Madam,
bit.
please can't hear you
Wait,
clear.
one at a time, one at a time. Hold on. Can others hear me clearly?
Yes,
Yes.
please.
Yes.
Yes.
Okay. Okay, whoever was talking before, keep talking. What was your question?
Okay, please. Now I said that if you draw this, if you draw this thing right now you're talking
Madam, please
about,
can't hear you.
if you are drawing this part you are talking about, and it is 10 centimeters,
I understand why you can't talk.
and it's 10 centimeters, and here
But
it's 6
you don't
centimeters,
have
and,
any speaker.
and it's a 3D shape. If it is a 3D shape, it has its dimensional, which means it doesn't
You
look
don't have
straight.
no
And if you come and draw it here,
That's why you
nothing
can't
is
talk.
here. Nothing is here, like the way it is over here. So it's a bit confusing.
Wait, can you say that again? There was a lot of background noise.
This I'm trying to say that if you are drawing this, you are trying to draw this type of shape, this one, the
Mm-hmm.
whole shape here, and you come here. It's like nothing is here. This is a 3D shape. So it kind of shows the outer and back part of it, the back and the front, the side and every part of it. Here it just shows the front like that. And if you write 6 here on the top, and there is nothing here at all to prove it, it doesn't make sense to me. So please, I was asking, could
Oh,
you so please could you make it so that it can look like the 3D shape exactly, and you can also understand at the same time?
okay. So basically what I have done is that you have this figure. Okay, so I have this 3D block right here, right? Can you guys see it?
Yes,
Yeah.
yes,
So
please.
basically, what the picture is showing you, it's like something like this. So you can see all the dimensions, right? Yeah?
Yes, please.
Okay, so
Yes,
what
please.
I'm doing is like, if I only want to see the top part, I'm just gonna flip the diagram like this. So now instead of looking like 3D, the diagram looks 2D, right? But it's still a 3D thing. Does that make sense?
Yes, please.
So basically, I'm just like orienting the 3D shape so it's that like you only see the top, and the top part is like now it looks flat. That's basically why I'm able to do something like this. So it's still a 3D shape. So like basically if you draw lines down, there's still a 3D shape. Something like that. But for simplicity purposes, we're just going to orient it so we can only see the top. And that's why you can draw it like that. Okay. So back to this. So we know that this entire yellow part is 10 centimeters, and we're given in the problem that the other remaining, like the part not including the green part, is 6 centimeters. So if that's the case, then we know that this portion is 4 centimeters because the side lengths have to be equal, right? So now we have all the dimensions that we can use to solve for our total volume. So I'm just going to clear the screen. Okay, so we know that this part is going to be 3 centimeters. And this part over here is going to be 4 centimeters. So now let's find all the volumes. So the volume of the bottom, we know it's going to be 10 times 3 times 2. Right? So this is going to give us 60 centimeters cubed. Then we have our next volume, which is going to be 3 times 4 times 4, which gives us 12 times 4 or 48 centimeters cubed. So now if we add our volumes together, we're going to get 108 centimeters cubed. Does that make sense to everyone?
Yes, please.
Yeah? Does anyone have any questions?
No, please.
Okay.
No.
Let me see if there's another. Okay. And then just homework. Oh, this should say homework. Ignore the classwork. So for homework, it should just be like, we should just try and submit it before class so I have time to look at it. And then I am still looking at your other like previous week homework, so I will get that done as well today. Does anyone have any questions on what we went over?
Still don't really understand it. Please can you go over just one more time?
Yeah, okay. Does anyone who understood it want to try and explain it? Because maybe you have a better way of explaining it than I do. Okay, I'll just explain it then.
Talk to me today. Yes.
So, what part did you not get? Like, where did you get confused?
It's like the whole graph. My computer went out, so I wasn't here when you were explaining.
Oh, okay. So, did you understand the way we like split the prisms?
Not really.
Okay, so basically whenever you're given any shape that looks a little bit weird, like let's say you have a shape that looks something like this. Or something like that. Anytime you have a shape that looks a little weird, you want to try and, you want to try and split it up into shapes that you can, like, you know how to find the area of. Or, yeah. So if we're looking at this one, how do you think we should split it? Such that we have, like, some prisms that we can easily find the area of. Like, yeah. Okay, so we can split it. We can split it right here, right? So now we have 2 prisms. So we can draw them like this. So here's our first prism. That looks something like this. Then we have our second prism. That looks something like this. Right? And then this one would be stacked on top of this, like this. Does that make sense?
Yes, please.
Okay. So then, so then let's start with the small one. So we know one dimension of the small one. We know that this part right here is 4 centimeters. Right? Then we need to know what this side is, or like what this side is, and what this side is.
Hey, hello.
Yeah? Right, so we need to find these two sides, right? So if we look at a side view, so if we orient this model such that we can only see the side of it, it look like this. It looks something like this, right? If we're looking just at the side.
Oh, darling. You were forgiving. 4 p.m.
Like, do we all understand how to do this problem already? Because if you do understand, we can do some more practice problems.
So, madam, please, if so, I understood the part where you were able to. I understood the part where you were able to break it down like this. I understood the part where you're able to break it down, like the 3D shapes. When you're able to break this top part from this part. But what I don't understand is like how you take these numbers away, because mostly I thought that if you are doing this type of work, you just add it. In fact, when I was in school, they taught us to do it by either multiplying everything by each other.
So you do multiply everything by each other. So like that's
So
defined.
you are trying to say that. So you are trying to say that I just multiply 6 times 10 times 3 times 3 times 2 times 4 to get my answer.
Okay, so I think in school you were only given one shape basically. So it was just looking like that, right?
No, please, I'm trying to say that you just multiply the 6, 10, 4, 2, 3 by all together to get your answer.
So so in this case, like to find the volume of a regular shape like this one over here, yeah, you just multiply everything together, like all of these together. But because
Then please, why in the old work you had to divide and subtract? That's the part I didn't understand at all.
okay. Okay, so basically yeah, if you understood how to do this problem, I think you can log off, but I'll stay on to explain it. So yeah, everyone who understood how to do this, you may leave if you want. Or like if you have any other questions, you can stay around. Okay, so basically when looking at a shape like this, you understand we have to split it up, right? So now what we have to do is we just need to find all the side lengths, right? So we can calculate all our volumes. So it's a little confusing to look at the diagram like this. So what I'm going to do is that I'm going to section off this part, right? So I'm basically going to turn the prism so that you can only see this side. So it should look something like this, right? where this top part is the green part. This top part is like the other, like one of the prisms, and this bottom part is the other prism. Does this part make sense? Like you're able to, I guess, like turn it so you can see the side? And
Yes.
Please.
yeah? Okay. So basically this is a rectangle, right? And we know that this side is 3 centimeters, and we know that this part is 4 centimeters, right? That's what we get when we look at the side. Well, and this part is 2 centimeters, right? We get a rectangle. Everyone understands that? It's a rectangle?
Yeah.
Yes, please.
Okay, so then what that tells us is that the width throughout the rectangle must stay the same. So like if you check here, this should be 3 centimeters. If we go here, it should be 3 centimeters. So what that tells us is that we know this length right here has to be 3 centimeters because it's also the width of the rectangle. Does that make sense to everyone?
Yes.
Yes.
Yeah?
Yes.
Okay, any questions so far?
We understand.
No questions, please.
No questions? Okay, that's good. Okay, so that gives us this is 3 centimeters, right? So now there's one more thing we need to find. We just need to find this part. So to find this part, instead of turning the prism to the side, we're going to look at the prism from the top, this way. So we're going to get something that looks like this, right? Where the yellow covers the entire portion over here because it goes from this to this end. And then the green only exists right here. Does that make sense to everyone?
Yes.
Yeah? Okay.
Please, could you do it? Could you do it like this? Could you color like this place extra long so we will know? I got confused when you mix the two colors together. So please, could you color this part extra long so this part will rather becomes the green and all this part becomes the yellow.
Okay, yeah, here I'll erase. Okay, so basically these are stacked on top of each other, but just for like looking purposes, I guess. It's green and then this is yellow and yellow. But they're on top of each other. You understand? Like looking at it from the top, this green portion over here is going to be right on top of part of the yellow portion. Does that make sense?
Yeah.
Yeah? Okay. So, in the problem, we're given that this whole length is 10 centimeters. And we're given that this portion of it is 6 centimeters. Does everyone understand where I got those numbers from?
No.
Okay. So do you understand where the 10 centimeters came from? The 10 centimeters is just like the width of it. It's just like how long it is. Does that part make sense?
Yes, please.
Okay. And then the 6 centimeters back here is just telling you that like from the start of the yellow to where the green starts is 6 centimeters. It's a little hard to tell because of the perspective, but if I were to draw the whole green sort of prism thing, something like this, right? This 6 centimeters would intersect, like this portion would be 6 centimeters. Does that make sense to everyone? Like, if I were to...
Yes, please.
Yeah?
Yes, that's it.
Okay, so then in order to get like how long this segment is, you just do 10 minus 6, right? So then you'd get this as 4 centimeters. And so then this part is 4 centimeters. Does everyone understand?
Yes, please.
Yeah? Okay. Then you just find all the volumes. So one volume would be 4 times 3 times 4. The other one would be 10 times 3 times 2. This gives us 48. This gives us 60. So then when you sum it, you get 108 centimeters cubed. That's it. Okay?
Okay.
Miss,
Okay.
have you assessed our homework?
Huh?
Have you assessed our homework?
I'll assign the homework like right after class. Like as soon as we
Miss,
end up.
we are submitting our homework at 7 o'clock.
Oh, the homework is due like just before class. Just before class.
Next week class.
Yeah.
Okay.
Okay. Well, that's it for today. Yeah. So I'll see you guys next week. Okay? Bye.
Okay.
Okay,
Bye-bye.
bye.
Bye.